All right, what's up, everybody? Today's lesson, we want to look at shifting and rescaling data, whatever that means. I suppose we should start by figuring out what that means, but probably we don't want to skip over this sweet title slide that I have. Why isn't this working? All right, here we go. So, shifting and rescaling data. Look at that masterpiece. So, to start, let's hit the vocab, right? What does shifting data mean? What does rescaling data mean? So, right off the bat here, so shifting data. This is a video, in case you couldn't tell. Shifting data is when we are adding or subtracting a constant to each value in a data set. That was a pretty bad box. So we're taking every single value in a data set, right, and adding some number to it. So for example, maybe I add 3 points to everyone's test grade, right, or give everyone a bonus 3 points or something, right? That's kind of an informal curve, right? That's not really what curving data means. We'll talk about that, right? But that's a lazy curve. I want to boost everyone's score. Or maybe a less like this is pretty realistic, right? Like this happens in your classes sometimes. Or maybe right at a store they say every item is $5 off. That's probably less realistic because then they probably have to like pay you to take some things home, right? So shifting data is when we're adding or subtracting some constant to every value in a data set, right? So we're adding the same thing or subtracting the same thing from every single one of the values in our data set. And what we want to investigate is we want to understand how measures of position, right? So measures of center specifically, mean, median, and stuff, but other measures of position, right? Like the quartiles or the min or max or whatever. We want to understand how those are affected by shifting. And then similarly, we want to look at how measures of spread are affected by shifting. So let's figure it out. So we've seen multiple times in this course, one strategy we can always fall back on if we forget these rules is just make up an example. So let's start with some made up data set. Keep it simple, right? Like don't pick random numbers, 72, 13, like nah, that's totally unnecessary. Let's just go with like 1, 2, 3, 4, 5. That's even unnecessary. I could have just gone 1, 2, 3. So from this made up data set in blue, let's kind of think about what are some simple measures of position and spread that we can look at. So like what's an easy measure of position? Oh, what's that? Oh yeah, median or min. Sure, I like both of those, right? So we can easily see here the median is 3, right? The minimum is 1 for a different measure of position. Sure, I could find the mean if I wanted to. It would also be 3. And then a simple measure of spread. We could look at standard deviation, right? We could look at IQR, but to make it super quick, right, we can look at the range here, which is 4. Right, whatever's true for these couple measures of position and spread is going to be true for all measures of position and spread. So I don't need to find all of the values in my 1-bar stats, although that would be quite easy, right? We can just kind of use these as a reference point. So now, let's say we're going to shift our data. And let's see what happens to these measures of position and spread. So, right, we could do anything. We could subtract something from every value. We can add something, right? Let's make it easy. We'll add 5 to every single data value. And then over here, right, so we're going to shift our data set. And then we're going to create this new data set after we've shifted the values, right? So this is our data after the shift. And so now, of course, we're going to have 6, 7, 8, 9, and 10, right? Just adding 5 to each of these. No big deal. And think about it. Find our new measures of position and spread. So our new median here, our new minimum over here, and our new range, right? So maybe pause the video, fill these out, and observe. You know, what do you see? What happened to the measures of position? What happened to the measures of spread or the measure? And now that you've unpaused it, right, we can see over here, of course, quite clearly, right? It's all pretty simple, no big deal, right? We can see the median is 8. We can see the minimum is 6. I made that work pretty well. And the range, right? 10 minus 6. I did not make that arrow situation work really well. Everything that just happened was a disaster. But the range is going to be 4, right? Maximum of 10 minus the minimum of 6. So what do you notice? What happened to the measures of position in green? What happened to the measure of spread? Right? And of course, as we look at this, we can see that the measure of spread is unchanged. But the measures of position, right, both of them did change. And how did they change? Right? Of course, we added 5. They shifted the same amount the rest of our data set shifted. So that's ultimately what we want to take away, right? Ultimately, we want to know that if we're shifting a data set, apparently my board doesn't like this corner. So if we're shifting, what we want to know, right, and that's adding or subtracting. The key is we have to be adding or subtracting something to every single data value, right? We added 5 to every original data value. Measures of position, which include measures of center, right? So that's part of position, just a specific position, are going to change. We add or subtract that same constant, that same number. But measures of spread, right, are unaffected. And if we ever forget those rules, right, we could just make up a quick data set, look at 3 measures of, right, 2 measures of position here, 1 measure of spread, not that it has to be that many. And you could have even just used 1, 2, 3, right, and kept it even simpler to do it quickly. So if you ever forget these rules, right, you can always fall back on the same strategy we used here. Now, just to kind of wrap this up, one last comment, help us better understand this, hopefully. If we're shifting a data set, if we think graphically here, let's kind of think about what's going to happen. So if we're going to, can I get that? Can I get that? No, I didn't get it. I was trying to extend the page. But anyways, if we're going to shift the data set graphically, so picture a histogram in your head. So if I take some histogram, right, and I then add to each data value. Now, I'm not going to draw a whole histogram because I'm being lazy. But let's say we start with some distribution, right? We're going to pretend there's a histogram under here, or maybe it's a bell curve, right? It doesn't really matter. But if we then shift our data set, right, +5, either picture, what do you think's happening graphically? Think about that. Pause that. Jot down a note, right? Jot down an idea. What do you think is happening, or what's going to happen to our graph? Right? We're pretending there's a histogram under here that I'm too lazy to draw, and it'll be real sloppy. What's going to happen to these bins if we add 5 to every data value? And hopefully you said something like this. All that's really going to happen is this curve. I mean, that was supposed to be the same curve twice, but I'm just not that good at drawing, right? It's just going to shift to the right by 5. Or here, right? This normal distribution that I've drawn, this bell curve, that was pretty good, is just going to move to the right 5. So we can see the measures of position are going to change, right? The original mean or median was here, now it's here. The original minimum was here, now it's here. But the spread is not changing, right? So the curve's not getting stretched out or squished together. The curve is just sliding left to right. And this is one of the rare opportunities we have where we can connect what we're doing in stats to algebra 2. Right? So if I look at f of x or y equals x squared, right? That's our parabola there. But if I go with x squared, +4, that's just going to shift my parabola up 4, right? Or of course, if I did -4, right, it's going to shift it down 4. So it's changing the position, right? It's changing like the vertex, that measure of position, but it's not changing the spread, right? It's not changing the width of the parabola. Right, so we can fall back on that algebraic understanding that we have, right, and use it in this context to think about how we're shifting a graph. Or we go back and make up our example. So shifting data, affects center, affects position, doesn't affect spread. So rescaling. Rescaling data is when we multiply or divide each data value by a constant, right? So rescaling up here, right? Now we're multiplying or dividing each data set, each value by a constant. Sorry. We're multiplying or dividing each value in a data set by a constant. Maybe, right, I double each person's score on an assignment. Like not make it go from a 50% to 100%, but maybe you got a 10 out of 20, and maybe I double everything to make it worth, right, just to make the total points more heavily weighted, right? That happens, right? I do that fairly often. Or another realistic example is maybe a store is having a sale. They're probably not just going to give you $5 off of everything, right? That's going to be based on a percentage, right? So maybe they take 10% off of everything. So rescaling, multiplying or dividing each value in a data set by a constant. There's a couple examples. And again, we want to investigate the same question, right? How are measures of position affected by rescaling? Whoops, typo, right? That should say rescaling a data set. And then how are measures of spread affected by rescaling a data set? So same thing. Let's whip up an example and see what happens. So we start, right, original data set. This time I'll just use 1, 2, 3. So some measures of position, right? Median or mean would work. Median's easy. I can see it immediately. This time to get crazy, I'll use the maximum instead of the minimum. Ooh. And then we'll use that same measure of spread, the range. And all the things we're doing, right, we could also use standard deviation, IQR, mean, right? The quartiles, right? We could get our calculator out and list all of those, but we'd see all the same patterns happen, right? So we're trying to do this as quickly as possible. So now, let's say we're going to rescale our data. So, right, there's all sorts of stuff we can do. We can work with percentages and stuff, but for now, just to make it simple, let's just triple every number. So we'll take every single number and multiply it by 3. Right? Easy enough. See if my pen can keep up. It can't. So over here, right, now our new data set after we have rescaled. Now we're going to have 3, 6, 9, of course, right? Just multiplying each of these by 3. And so we can see, right, the new median is 6. The new maximum is 9. And our range is also 6, right? 9 minus 3. So again, I want to make those observations. And what do we see? Maybe you pause the video. You know, we wrote that orange box, right? Shifting data affects measures of position and center. We add or subtract the same constant. Shifting did not affect measures of spread. So maybe you try to write up that orange box, right? That kind of notes recap yourself, just making your own observations looking at these values. But of course, we can see that this is probably a bad color choice, right? This value changed, this value changed, this value changed, right? And they all got multiplied by 3. So rescaling data affects everything or changes everything, right? So rescaling changes all of our measures of position and spread, right? And remember, position includes the center. That's just a very specific position. And how does it change them? We multiply or we divide by that same constant, by that same number. So sure, we want to remember these for the AP exam, right? We want to know these rules of shifting and rescaling, but if we don't, now we've got a way to figure them out with a quick example. So let's take a look at a couple practice problems, kind of see how we might apply this, and that's it. So next slide, here we go. Kind of the way I might kind of kill my vibe there. So we've got a specialty foods company that sells gourmet hams by mail order. That sounds ridiculous. The mail order part is ridiculous, but I can tell you that one time my grandma took me to a store on the Berlin Turnpike to buy like a ham for Easter or something. So I know that a ham store, at least at one point in history, has existed. Anyways, our hams have a mean cost of $22. They have, I'll go green because that's position. I'll keep that going. So the mean is $22. The quartiles and medians, so Q1 is 10, the median is 19, Q3 is 27, and then for spread here, we're given a standard deviation of 650. And just for fun, since we can, let's add the IQR, which is going to be, that's correct, 17, right? Q3 minus Q1. So we've got 2 questions here. Part A, if we offer some kind of sale, we take $5 off the cost of each ham. What are our new summary stats going to be? We want to find the new values over there. After we subtract $5, what's going to happen to all those green numbers and red numbers? And then second, instead of a more realistic example, maybe what if we're going to cut prices? We're going to take off 10% from each. What are our new summary stats? So let's do it. Let me just copy and paste this. I don't have to rewrite all these things. So as we think about this, part A. If we take $5 off the price of each ham. I think I had a slide for this. Yeah, I did. It's like So, first off, shifting or rescaling. Right? Well, hopefully we clearly recognize that it's shifting because it literally says the word subtract $5. Maybe it would say the word discount $5 from each ham, and then we'd have to think a little bit more. But so we're going to now shift our data set, take $5 off the price of each ham. We want to know what's the new mean, what's the new Q1, what's the new median, what's Q3, and then standard deviation and IQR, right? So you pause this video and jot down your answers, see what you think. And like, if they're wrong, so what? Then we'll correct them, right? And you figure out what you did wrong. That's life. Make mistakes, learn from them. That's how you learn things. I'm going to say that like 82 billion times this year. So now that you've unpaused after your own attempts, hopefully Shifting, right, changes measures of position and center. So this average will change. The average is going to go down $17. The first quartile, right, that's a measure of position. That will change. So that's going to go down $5. The median, that's going to go down, right? That should make sense, right? If all the prices are going down $5, probably the median price is going to go down $5. And then Q3, same thing, right? This is now $22. And right, if we picture our distribution, I don't know what shape it would look like, but whatever the histogram looked like, I don't know, maybe it's skewed left. Maybe most of the hams are really expensive and there's not that many tiny little cheap hams. After we subtract $5, right, this curve is just going to shift to the left 5. So our measures of position, right, max kind of right here, median-ish right here, right, min over here, are all moving to the left by 5. But hopefully, you realize that measures of spread are not affected by shifting. So down here, measures of spread are not affected by addition and subtraction, by shifting, right? Because they're just sliding the curve to the left. So our measures of spread are actually going to stay the same. That's pretty terrible handwriting. All right. Whereas for these, for all of these, right, we're going to subtract $5. That's it. So this could be an AP multiple choice question, could be an open-ended where we have to find some new summary stats, but we want to be able to start with a list of summary statistics and use our knowledge of shifting and rescaling to be able to report the new values of the summary stats. So let's jump ahead to B. So question B says, what if we discount each ham by $10? So if we're going to do that, if we discount each ham by 10%, it's late at night. Give me a break. So here, what's happening, man? What's happening? I'm panicking. The mean was 22. Oh, they're all up here. I didn't have to do that. Q1 was 10. Median was 19. Q3, sorry, was 22. And then we've got our standard deviation and IQR. So standard deviation 650. IQR is 70. So now, right, we're going to shift. Now we're going to rescale. What are we doing? I don't know. We're going to discount each price by 10%. So here's where it gets tricky. Like if I said, take a 10% discount. Sometimes students think that we're shifting because, right, like let's say we're taking a 10% discount off of $20. I don't know. So what a lot of people do, right, is you're going to tell me you're going to do 2.1 times 20, right, which is 2, and then take the original price and subtract that 2. So then students get caught up in this subtraction right here, and you think, oh man, this is shifting, right? Maybe that's not affecting my measures of spread. But I want to emphasize, and when we're finding a percentage, that's rescaling. One obvious way to see that, what I would recommend is rather than doing this multi-step approach, we can just do 0.9 times 20, right? We had 100% of the original price. We're going to take off 10%. So that means we're going to be paying 90% of the original price, $20, right? That's where this is coming from. And of course, if I did a little algebra here, I could rewrite this as 20 minus this 2 came from 0.10 times 20. Right, so this is that 0.10 times 20 I just wrote. And then if I got crazy and did some factoring, I could factor out the 20 and I'd be left with 1 minus 0.1 or 20 times 0.9, right? So we can really, these are the same approach, right? But it's more obvious with the purple, right? But even when we do that, multiply first and then subtract in black, right? If we do the algebra to kind of rewrite that, we can see that this is rescaling. So taking a percentage discount or adding a percent to something, right? That's rescaling. If we were going to increase prices by 10%, we'd want to multiply by 1.1, right? Because we'd have 110% of the original price. So my advice to you is to think of rescaling as times 0.9, rather than thinking of it as 0.1 times 22, then we get that answer and we subtract from 22, right? Which is the same thing we could see over there on the right in the algebra. That's just my advice. So again, right, so now we want our new mean. We want our new standard deviation, our new Q1, our new median. I'm rusty out here. Our new Q3 and standard deviation in IQR. Take a minute, right? Pause the video. Try it out while I get out my calculator. So here, you've now unpaused the video. Right here, everything's going to change. So rescaling changes everything. Our new mean is going to go down by 10%. So it's going to be 1980. Our Q1, I'll type that in the calculator, is going to go down by 10%. That's going to be 9. We're going to do 19 times 0.9. That's going to give us not 171 because that makes no sense. That's going to give us 17.1. And then we're going to do 22 times 0.9. And that's going to give us 19.8 and so on and so forth. If it wasn't late at night, I would be doing this in my head. Don't judge me. Don't judge me. It's not like I get bonus points if I do it in my head. I paid a lot of money for that TI anyways. Might as well use it, right? And then 17 times 0.9, 1630. Oh, 1530. So rescaling, everything changes. So if we're rescaling, right, we take every single value and we multiply by 0.9. So no big deal. One more, let's do it. So in this example, last one, a little more complicated. So we've got some high school seniors, got some info on February temperatures in the town he's going to go to college, and all his summary stats are in Celsius, right? Because like that matters, of course, the major matters, the type of school and all that. Maybe you're worried about the temperature of the climate. That's legit. That's fair. So this person, maybe they're going, I don't know, McGill University in Montreal or something. They're going to school in Europe or something because all of their temperatures, right, are in Celsius, which I should not have written in green because I'm trying to only keep my measures of position in green. But our median is 2. Our mean is 1. The range is 33. And the standard deviation is 7. And we want to know what are the new summary statistics if we convert everything to degrees Fahrenheit. Now, of course, you wouldn't be expected to remember this on the AP exam, but I always liked in class to kind of see if anybody remembers how to convert Fahrenheit to Celsius or Celsius to Fahrenheit. We want to get Fahrenheit based on the temperature Celsius. And the only reason you might know this is from science class, so this is a pretty classic linear equation in Algebra 1. And maybe you remember that it's going to be 9/5 C plus 32. Or right, I said 9/5, but I wrote 1.8. Right, and if you don't believe me, you can plug in, we can make sure, right? Let's plug in the boiling point. So boiling point is 100 degrees Celsius. So that would be 180 plus 32, which is 212, which is also the boiling point Fahrenheit. So that equation works. Again, you would not have to know, right, the conversion formula for Celsius to Fahrenheit on the exam. This would be given to you, right? I'm just throwing that in there, you know, because why not? So your challenge, pause the video. Using that equation now, can you tell me the new median in Fahrenheit, the average temperature in Fahrenheit, the range and standard deviation of temperatures in Fahrenheit? And I bet, right, because you like unpaused it now, right? I bet I'm going to see a lot of this. The new mean, 35.6. The new median, 33.8. You're like, where'd those come from, right? We're just plugging the number into the formula. 1.8 times 2 plus 32, right? And then 1.8 times 1 plus 32. And then I would bet I would see a lot of this. 1.8 times 33 plus 32, which gives us a new range of, probably should have done this beforehand, right? 1.8 times 33 plus 32 is 91.4. And then same thing here. I think I could do that in my head at the moment. 12.6 plus 32, 44.6. All right, so I bet a lot of us at home are writing those values as our final answers. And that's pretty good. That's not bad at all. Unfortunately, they're not all right. If we look in green up here, green, we're good. Measures of center, they are affected by shifting. That wasn't really a good box. And they're affected by rescaling. So for the measures of center or any measure of position, this is good. We're just going to plug the number into the formula, right? The shifting affects center and position. The rescaling, the times 1.8 affects measures of center and position. So we're good here. But what's the mistake in red at the bottom? Are measures of spread affected by rescaling? Yeah, they are. We figured that out. But are measures of spread affected by shifting? They are not, right? So if we shift a data set, that does not affect measures of spread. So these are incorrect because we should not add 32. Only the rescaling part of the formula is going to affect our measures of spread. So our range will actually be 59.4 degrees Fahrenheit, and our standard deviation will be 12.6 degrees Fahrenheit. And of course, right, so these are all degrees Fahrenheit, right? We're converting from Celsius to Fahrenheit. And that's it. So that's kind of as tricky as it gets. We got to recognize that not every element of the formula is going to affect the measures of spread, because spread is only affected by the rescaling, whereas the measures of center, the measures of position, we don't have any specific positions here, right? Other than center, right? We don't have any min-max, Q1, Q3. But the measures of centers and position, those are affected by everything, shifting and rescaling. So we do apply the whole formula. So that's it. That's shifting and rescaling in a nutshell. Some practice coming up, and I'll see you guys soon for some normal distribution and z-score.